You guys had fun today? Yeah. It's an exciting time in the field. Yeah, there's a lot going on. Yeah.
Oh, yeah. Thank you so much for joining.
Yeah, well,
So to kick things off, I have a question for you.
all right.
So AI has changed a lot recently, and it's becoming so much more accessible. So what kinds of cool things can developers do today with Gemini that a few years ago would have taken an engineering team or research team or tons of work?
I think you all are doing it already. I've seen crazy examples online. It always blows me when people think about stuff before we do. But I think it's going to take us a while for us to internalize what multimodality means. The fact that anything in any input can come out as any output, and you can mix and match and do things. I think it's a powerful new thing. All of us are putting the plumbing in there, but I think you get to use it and think through in a big way. Obviously, long context, something as we make it more and more easy to use. We introduce the caching API coming soon. As we bring the latency and cost down, I think that's another dimension on which it's pretty powerful. And finally, as things become more agentic, I think, an extraordinary opportunity to kind of push the boundaries on. But I'm always blown away by what people do rather than me telling them what to do. Yeah.
So we have a lot of developers in the room, I think. Yeah, we got a few. So speaking of developers, Sundar, how do you see the developer role changing in this new AI world?
Well, the pace is pretty fast, but you're also getting new tools to go with it. So embracing AI in your workflows more natively is going to be important, I think. But also, I would say, you have to challenge the existing assumptions across everything you do. When I spoke about multimodality, that's what I meant. You're just really internalizing it. I think it takes time to internalize that you can actually go from any input to any output in a deep way. So I would just say, internalizing what it means to be AI native, I think it's going to take some time. When mobile came, we all went through the same thing. Most of us did what was in the web, and we kind of shoved it into mobile. And then people started doing really mobile native applications. I think we're in the same phase with AI.
Okay, once again, hi everyone, and welcome to today's webinar. I'm so happy to have you all here. And right now we have our speaker in here with us. Hi, Venkatesh. Hope I didn't kill your name. Hi, how you doing? You look great. If you're speaking, you're muted, but I'm just going to introduce you. Okay, yeah. Hi.
I'm good, thank you.
All right, good to know. So in today's webinar, we're going to be talking about enhancing developer efficiency through automated platform engineering and IDPs. So basically, we all know that we are in a fast-paced software development arena, right? And you're always pressurized to deliver high-quality apps quickly, and most times you even encounter repetitive tasks, right? And most times this can be so overwhelming, and you don't even know how to navigate through things like this. Right, so today, going through platform engineering, we're going to learn how to use internal developer portals, which is the IDPs, which automates infrastructure management and provides pre-configured tools, and also teaches you how to enhance your workflow. So our speaker here, I'm just going to read a very short bio about him. He's a seasoned DevOps engineer. If you don't know who he is, he's a seasoned DevOps engineer with over 15 years of extensive experience in various technical roles, including site reliability engineer and build and release engineer. Okay. He also holds a Master of Science in Computer Engineering, which is super cool, from California State University, Long Beach, and also a bachelor. He's also a Bachelor of Engineering in Electronics and Communication Engineering, right? He has also demonstrated hands-on expertise across a wide range of DevOps tools and processes such as CI/CD, automation, configuration management, and much more, right? His professional journey includes impactful roles at companies like Flexport, Tata Consultancy Services, and others, where he has significantly improved productivity and operational efficiency through innovative automation and best practices. So I can go on and on to ramble about who our speaker is, but I'm just going to let his works, you know, show who he is right now. Like, I'm just going to allow you to listen to him and see what he's all about, right? So hi again. Hi once again.
Hello.
Yeah, hello. So the floor is yours. You can, go on and show us what you have for us today. Thank you.
Thank you. Um, can you see my screen?
Yes, we can.
Yes, we can.
Yep. Thank you very much for the introduction, Joy, and hello all. So, as Joy mentioned, we are going to talk about enhancing developer experience through automated platform engineering and internal DevOps portals, IDPs. Um, so yeah, first, we are going to talk about the sequence of like how we can achieve operational efficiency with through internal developer portal. So we'll go with introduction, what's the exact challenge, the solution, and what is platform engineering, the role of internal developer portals, and IDP benefits, and the combination of platform engineering and IDPs, and then some of the sample IDP tools we have in the industry, and we'll see some metrics that are achieved after implementing IDPs, and then the strategies for continuous improvement, and we'll go to the conclusion part. So uh, so as we already know, like the software development landscape is rapidly evolving, putting immense pressure on development teams to high quality applications at an unprecedented pace. In today's industry, we have a very challenging environments where we need to deliver software quickly as soon as possible, time to market, and to be competitive in the market. And developers often spend unreasonable time doing undifferentiated heavy lifting rather than focusing on application code. So the times I see, in the projects, for example, if and I have given an example here. Suppose that you have a Java microservice running on cloud Kubernetes, and we are asked to, hey, can we start working on a microservice in Java? Then the developer, generally the first thing they would do is, okay, hey, we have to do a couple of things, like create GitHub repos. Then you need to build scripts. You also need to run CI/CD pipelines, Terraforms, and you also need to write Docker files, and Kubernetes deployment generally the trend I see is, like, mostly developers at least, like, go and clone somebody else's repository. Suppose there is a developer that joined the team, company new, so they will just go and, okay, hey, is there an existing service that I can clone, and then start tweaking the information there. So that leads to more error prone. That's what I was like, that's how it works, and then that is more error prone and more frustrating, repeated iterations to make it work. So this hinders developer productivity, taking away their focus from app development. So it takes at least like a 1 or 1.5 day to get to the point where they can start actually writing code and building and deploying and testing. So, and especially for new developers that join the company, it will be more challenging because they have no idea of the tech stack or anything. So it will be very challenging for them to fix the and then they need to talk to others, and hey, how can I fix this? There's going to be a lot of losing time on productivity. So the solution. So if we ask, like, how soon can I get a quick environment? I don't want to spend a lot of time, and all I want is, like, I want a quick environment, a quick code, some sample code, a skeleton code where I can start developing my application. So that brings us to platform engineering through developer portals facilitated by internet developer portals present a strategic approach to elevating these challenges. So platform engineering is the latest concept that, like, all the companies or all the corporates are trying to adopt to actually make it easy for developers or for all the teams within the organization to move productively. So IDPs is in combination with platform engineering provide a pre-opinionated and pre-configured tools and environments, freeing developers to concentrate on their core responsibilities. And then what is platform engineering? Platform engineering's primary goal is to lessen the cognitive burden on developers by offering automated process and reliable tools. Design, development, and management of a combination of software and hardware provide foundation for developing, running, and managing applications across the organization. And platform engineering, the main purpose of platform engineering is, like, just platform as a service. So all the software and infrastructure within the company can all be a single platform, and whoever wants to use whatever piece of the platform, can, let it be an infrastructure team, let it be a development team, all they just go and just use the platform. So the key aspects of the platform engineering is development platform. So, and first purpose is auto provisioning of development environments. It is build scripts, tests, and skeleton codes. Developers can quickly go and from the platform they can quickly get a development environment. So which means is, like, they access the platform, and they get the required development environment, like, and then the underlying infrastructure, everything is maintained by the respective people in the responsible for the particular component within the platform engineering. And also developers, they need a deployment pipelines. For example, they need an automated pipelines to release software at any time. For example, GitHub workflows, Jenkins pipeline scripts, etc. And also you need we also need like, again, we are all talking from the perspective of a developer here. So infrastructure provisioning. So developers quickly need some kind of an infrastructure to start developing, deploying, and testing their code. So so they need to be provided the underlying Terraform, Cloud, whatever technology we use, like, if we use GDP, or we use whatever technology we use, AWS, or we use Azure. So anything can be. That's what, like, the beauty of platform engineering is. Developers don't need to worry about, like, what is underlying infrastructure, or hey, what is the CI/CD tool I'm using, or what is, everything will provide it to the platform. So interoperability and integration makes it easy for new technology integrations and rollouts. For example, let's say in the company, like, we want to bring a security tool, or we want to bring a new tool to be integrated with the software. So one strategy is you email all the developers in the organization, hey, now start adopting this library into your current project, versus in the platform engineering, you integrate it into the platform engineering. So whoever whoever starts a new project from that platform will automatically get that feature, hidden feature, without any communication. So that's the beauty of platform engineering. And then role of internal developer portals, basically, so interface between developer and platform. So you need, obviously, when platform handles all the self-serve, when platform hidden or hides all the details from you on the backend infrastructure. So the IDPs, internal developer portals, are the interface, like, it's like a self-serve centralized hub for organization software development activities through an intuitive web portal. Mostly it will be in the form of a web portal where you just go and start interacting or start doing things that you want from the platform. So developers can provision fully configured environment for new projects by using ready-made templates. So within the platform, you maintain some like, for example, again, in platform engineering is a collaboration. So like, for example, pipeline infrastructure team maintains the pipelines, or the infrastructure team maintains the underlying Kubernetes configurations, and development teams, suppose like as I mentioned an example here. So you just log into the IDP, choose template of your choice, for example, Java, Node.js, or Python, and provide inputs like a project name, project team, project email, etc., and then get all necessary setups within minutes to start coding right away. So again, as I told, like, again, for example, there is a Python template, like, suppose you have a Python lead within the architect, like a Java architect within the company. So they would generally maintain those templates. So they, like, suppose they want to integrate a new technology into the existing Java for the Java project, so they would go and integrate that with that. So it's a platform engineering is again a collaboration between all the teams. So people, like, everybody like does their own part, so it benefits the whole organization. So as I mentioned, an example here. So now, if you observe the previous example, you go and take from close some other repository, start tweaking code, start tweaking names, and then you do all that hassle things, versus how it would be like you just go to the internal developer portal, and you choose a, for example, a Java template, and then you get a working hello world skeleton Java code and test. A GitHub repository will be created for you with a skeleton Java code and test, a GitHub action. For example, let's say you're using GitHub actions as your CI/CD, so you get the automatic workflow, and you get a skeleton Docker file, you get a Terraform file executed on repository creation that provisions a dev, test, and prod namespaces. For example, let's say my microservice goes into Kubernetes. So as soon as you just go and select it, all these are running in the backend, and you get your Kubernetes namespace provision, as well as, let's say, you want to store your build artifacts in Artifactory. So all these are happening in the backend. For the all they just need is fill some inputs, and then boom, like everything comes to them in minutes. So and then templates can be owned and maintained by DevOps and infrastructure teams. Yeah, I mean, it's very interchangeable in some of the corporates, like, you have, you call it DevOps team or infrastructure team or platform team. Mostly, like, they would be generally, because most of the time, while application teams are only focused on their templates, but there are a lot of other things, like, making sure the infrastructure is right, CI/CD is right, all, like, the major part is all CI/CD infrastructure, which we don't want developers to focus on, because their focus should be on app development, so that their productivity and focus area should be that, and while rest all of the platform things can be taken care by the other teams. So I'm like, I just I'm just showing here a repo with internal developer portal. So if you see here, your microservice A, so you get .github, like generally in when your GitHub actions comes with under .github workflow CI/CD.yaml, and you get a Docker file, and you get a Kubernetes manifest, and then you have source main Java, source test Java, all this skeleton code and Terraform, and then you have a build.gradle. So, and then in CI/CD YAML, you would again, the platform team would automatically write it in such a way that as soon as, like, as soon as the repository is created, go and do like, that's how you design. So when you create a repository, the Terraform scripts will be automatically executed in the backend, and then yeah, you integrate scripts in the backend that will go into the cloud and create all your namespaces, etc. So by the time you're cloning to the repository, everything is already ready. Yeah. So IDP benefits is definitely, we have a lot of benefits from internal developer portals. So one is standardization and best practices, ensures all teams follow the same best practices, more consistent and maintainable high quality code. So for example, let's say you have different, like, hey, suppose you have a startup where, like, there are some teams working on Java, or some teams working on different kind of. So there you have your own, so all of them will have a same pattern of, for example, and microservices. So all the microservices gets the same kind of features. And then easy onboarding, one-stop shop for all organizational resources, so new developers can quickly learn technology stack and start contributing to projects right away. So I see most of the time the challenging thing is for the new developers who joins the organization, has to connect a lot of dots to actually understand the whole technology stack, because and then they will end up like, has to ask other teams, hey, I got this issue, how do I fix this? So it takes some time. So now let's say, like, you have an internal developer portal where all the documentation about the architecture, everything is available. So developers just go and read things and connect the dots, and they can, you go and create a sample repository and, start like, learning by themselves. And developer productivity boost. So centralized access to tools, documentation, API enables developers to focus more on coding and innovation and less of administrative tasks. So yeah, obviously we don't want developers to spend more and more time trying to figure out things that are out of their area. I know, like, there are some developers, like, we can say, like, some developers are pretty much interested outside of their area. Yeah, they will always go and explore. But some of the developers are not pretty much interested in, like, more of they're more interested in their app development, and they don't want to focus more on the underlying infrastructure, so which has to be taken care automatically. Yeah. And then the resource management, centralized monitoring and management of services and tools make it easier for platform DevOps and infrastructure teams to manage updates, monitor usage, optimize resources across organization. So for example, let's say, some right now, like, for example, in the backend, Kubernetes is adding more costs, and that an infrastructure team decides, okay, hey, we need to reduce some resource. So they don't need to go and, email to all the existing development teams, hey, now go and start, making changes, going forward, reduce some, hey, go here. And they don't need to give any instructions how to, because as I mentioned in the previous slides, today generally in a microservice, the infrastructure code, CI/CD code, application code all resides in the same repository for the purpose of isolation. So it's like, now we don't need any infrastructure team to start like reaching out to every team and, hey, make these changes, or for future projects they send communications. All they just need is go to the backend template, where, just go to the backend templates, from where developers consume these features, and just make changes there. So all the developers get the updates. And also cost management. By improving developer efficiency, standardizing tools, and reducing administrative overhead, IDPs can lead to significant cost savings. Like, as I already mentioned, uh, you know uh, developer efficiency, because developer productivity is also a cost to company. Sometimes it's like, it's not given a much focus, but the more developer productivity and developer happiness index, and the more they focus on innovation, so it's also a cost to company. We don't want them to get frustrated, or feel like, okay, we don't want them to keep connecting the dots to make things work. So yeah, so that also is a cost. And also, yeah, and administrative overhead. So as I told, like, you don't need infrastructure teams or pipeline teams to start reaching out to developers, and then communication. All these are avoided through IDP portals. All they do is they silently maintain in the backend all these, whatever they want to maintain through platform, and through IDPs developers consume it through IDP portals. They consume all these features. And now the platform engineering plus IDPs as a combination goes hand in hand for streamlining and enhancing software development process in the organization, and seamless integration of backend systems with front-end accessibility. And platform engineering creates the system and tools, while IDPs make them accessible and user-friendly for developers. Dual approach for robust application and infrastructure across the organization. And as organizations grow, platform can scale the infrastructure to meet increasing demands, and IDPs can be adopted to include new tools, resources, and support mechanisms. Yeah, routine task and streamlining process lead to a quicker time to market and better quality products. And obviously, the idea is to achieve more with less overhead across multiple disparate systems. Yeah, the whole idea of the combination of platform engineering and internal developer portals is maintain all the backend systems by the platform teams, while and then through IDPs, all the front end is provided through IDP, and whoever the consumers just go and clone their and consumers use the platform to actually be more productive on their projects. Now, and some of the IDP tools, or are like, Backstage from Spotify has been a they have come up, like, Spotify has a good story. they developed these internal developer portals, which you can see on their website, like backstage.io. So Spotify has a lot of webinars and a lot of informative videos on how they were able to achieve internal developer portals. Yeah, so Backstage is a very famous internal developer portal. And then we have APG API developer portal. And then we have Swagger, supported by Smartware, Red Hat, 3-scale API management, README, and Kong. So yeah, these are the different internal developer portals available in the market today. So yeah, so through which you can you can design your you can adopt into your company and start reaping the benefits. Now, here is a sample templating in Backstage. So a sample IDP. So where you can see that developer log in to the portal, and then they can see, hey, documentation template. Again, the documentation is also very important part of the organization. So you can have a documentation team keep updating the documentation for the new developers to understand the technology stack, or whatever you want to communicate, or whatever you want, keep updating the technology stack. And also here we can see a React SSR template and a Spring Boot gRPC service. So all they need is just go and select that, and then they'll have a list of things to input, like what is your team name, what is your email ID, and what is your project name, and then everything gets created as I shown before within your repository. And yeah, here is again in Backstage there is a feature called catalog. So where where you can this Backstage, Backstage is a technology where Backstage itself is a server technology, where and the clients resides in the repository. So you can create some catalogs within your repository, and for example, you have a microservice here, and you want to you can create a catalog, like this is the feature that I'm providing, and these are the APIs that you can access. You can write API contracts, and Backstage goes and consumes your catalog within your repository, and puts it on the portal. So anybody can go and click on the catalog and see, what is your microservice doing, or what are the API contracts that I can consume from your microservice. Yeah, so I mean, again, I'm not going into details of Backstage here. This is how one of the beautiful tool that Backstage provides, a very nice and efficient internal developer portals, where you can maintain templates, we maintain documentation, and where you can maintain catalogs, etc. And yeah, so metrics, very important. Developer experience is the metrics that matter the most. Yeah, so definitely one of the very important aspects. So yes, these are some of the metrics I gathered, from the from various projects. So number of developers and man hours before versus man hour after. So there is a 40% productivity improvement for the different types of technologies and the developers working. So the time they had to spend before to get their technology working, or their project working, versus the time they have to now, the improvement of the productivity has increased drastically with use of internal developer portals. And again, the dev satisfaction before versus dev satisfaction after using internal developer portal. So the previous one is all about the man hours, and here the satisfaction, the happiness index, number of us that has said, hey, yes, internal developer portals has made our life easy. So yeah, there is a substantial amount of improvement in the developer happiness index. Yeah, and then we'll come to the last part of the presentation here. The continuous improvement is the key. So for internal developer portals, so regular assessments. Obviously, in most of the organizations, as I already mentioned, developers focus on their app development. Rest of the platform is, as I told, it's interchangeably within the organization. We let it call platform engineering or a DevOps team, whoever. Yeah, they are the ones who make sure that the health of the platform is fine, and there is no downtime, and anytime developers can go and start consuming the platform, or internal developer portals, and access the platform. So one is the regular assessment. So assess platform infrastructure and applications for performance, cost, and scalability. So yeah, the platform has to be we need to keep assessing the costs that the infrastructure costs that are that we have that the underlying infrastructure costs that and also the performance, performance of the platform, and the scalability. So how scalable is the platform, and automate more processes. So wherever we see tedious manual task, it should be automated as much as possible to free developer burden. Suppose you identify, suppose I'm a platform engineer, I obviously I'm a DevOps engineer or a platform engineer. I keep interacting with developers, and then somebody says, "Hey, this is a more repeated manual process that can be." You identify some any manual process, so just go and automate it. Like, try to put it within the within the automation framework, so that it can be easily the no, for the developers, no need to spend much time on that manual task when they are working on the project. And the feedback loops, so regularly getting feedback from developers to identify pain points and areas of enhancement in the portal. So yeah, so obviously no platform is perfect. No not like, if I say, like, if everything is perfect, then there is something wrong. So you will keep seeing, there will be always scope for improvement. Like, you will keep getting feedbacks, and then um, yeah, so one for sure is we need to make sure nothing breaks, and that's the very first agenda is there is no frustration for developers using the platform. So that should be always healthy, and then there is always scope for improvement. So we'll keep getting feedback loops from developers. Hey, how, like, how are you for the platform? Do you think anything should be increased? So yeah, and then keep taking feedback loops. Maybe we can create some surveys as a platform team and send developers, and they actually give and then feedback, like, and we keep some features, and what how do you like this feature, or do you want this to go away, or you have your comments, kind of feedback loops. And updating documentation, keeping the documentation up to date with the latest API changes, best practices, and tutorials to ensure it remains relevant and useful. Obviously we don't want to not maintain documentation, because we don't want a new developer to come into the company, and then when they start understanding the technology stack on their own, they see a lot of gap in the available documentation versus what exactly is happening. So yeah, so we also need to definitely maintain up to date, keep updating documentation. And even as I told, even in your own repository, when you want to publish some documentation, yeah, every microservice keep updating the documentation. Obviously the relevant microservice team has to keep updating the documentation for the microservice, and the maintenance of the platform need to keep updating the technology stack, the overall architecture, whatever the latest technology stack has to be updated in the documentation. And the tool integration, continuously evaluating and integrating new tools that can enhance developer productivity and efficiency. So as I already mentioned before, suppose, like, you want to introduce DevSecOps, or let's say you want to introduce within the CI/CD pipeline. So you can just go and let's say you whatever library, suppose there is a library that has to be called as the build process. So we can just go and change underlying template, as it, like, developer portals are enabled through templates. So you can just go and modify the underlying Java template or Python template, whatever it is, to introduce this new module, so that it goes to all the respective development teams. And yeah, so performance monitoring, so implementing and improving monitoring tools to ensure the portal remains and reliable. Obviously we don't want any downtime on the portal, so people the IDP portal itself should be always available. It should not be prone to any vulnerabilities or security aspects. So that, again, the portal itself is a software by itself. Again, Backstage from Spotify, you can maintain it within your company, and there are some companies which are commercially available. So depending on what type of portal it is, so you need to make sure that it's always up and available. And then you also need to maybe you should have some monitoring tools that monitors the portal itself and give alerts to the platform team, and then inform the platform team, like, if there is any issues or any downtime on the portal. Yeah, in conclusion, so yeah, in the rapidly evolving software development landscape, platform engineering and internal developer portals have emerged as a game-changing solution to enhance developer experience and operational efficiency. by automating infrastructure management, providing pre-configured tools and environments, and streamlining processes, developers are empowered to focus more on innovation. So yeah, again very important. Platform engineering and IDP portals sole focus is developer experience. The more developers are free of managing their projects, and they get more time to work on their app development or service development, and they obviously produce very good products that leads to the operational efficiency with the company, and then obviously the overall success of the organization as a whole. Yeah. Yeah. Thank you very much for listening my session. Yeah. Yeah. Yeah.
No, thank you very much. Thank you very much. It's very awesome to have you tell us about tools that we could use to automate deployment so that we could actually focus on code rather than thinking of the platform. So this is a very much enlightening talk. And please, I don't know if we have questions. If you have any question, you could just type it in the chat. And
Yeah, sure. Yeah, so we have any questions or yep, so welcome. Yeah. Yeah, is there any questions on the chat? I don't see. Yeah.
I've not seen any question yet. So, but I think, yeah, you mentioned some tools, some IDP tools, backstage and the rest of them. At first I was thinking probably it's you actually targeting on one, but I think there are a number of IDP tools, platform engineering tools. So I don't know where does IDX fall in. You know about IDX? Google just launched ID IDX. It's idx.google.com. I think allows an IDE online that provides templating too. Something like that. Does it still fall under this IDP? Could it be classified as that?
I have not heard. I mean, maybe I'm not aware of that. But what is the features that it provides? The one that the Google launched the product. Is it doing the similar kind of? Is it providing the similar internal developer portal kind of features what we just discussed?
I think what's mostly what I know it does. It's yeah, it does kind of takes your IDE, your normal integrated development environment, in a normal VS
Yeah.
Code.
Yeah. So
Yeah.
internal development environment is maybe IDE versus IDP. So internal development environment is more about like IntelliJ or we have PyCharm kind of like where it's more of a developer can go and use it as an uh, IDE, and maybe I have to explore it like if it is actually because for me IDP is you should have a UI interface, and then where you can go and maintain some templates or maintain documentation or maintain service catalogs. So we have to check that, like what features it's offering. So but IDE, as I know, like internal development environment is more about most like an IntelliJ or a PyCharm where you can go and it's more about allowing developers to quickly write code and search things or like and integrate plugins while they're working on the development. Yeah. So
Thank you very much for that clarification. That's a good insight.
any other questions?
Please write your question in the chat, please. If you can unmute yourself, fine. I know we introduced you earlier, but can you just go ahead and just tell us more about yourself, because I know things have changed. Can you just tell us about yourself, But meanwhile, before that, welcome to this GGG Cloud Port Harcourt, Nigeria. And so ordinarily, so this is a session that we had planned for IU Extended Port Harcourt, but because we had a time frame and we couldn't accommodate all sessions, and we said, okay, this will be very good to have a separate webinar for it. And then we so much thank you for agreeing to speak to us. So I just wanted to use this opportunity to welcome you to the community and for giving your time, despite the time zone, we're able to make our time to join us at this hour. So just give us a little introduction about yourself so that we can actually know probably how to connect with you, where you are, and probably those that are interested in DevOps and stuff like this can actually know how to get across.
Yep. I graduated, I mean, in 2004 as a Bachelor of Engineering in Electronics and Communication. So I'm from in the southern part of India. So I graduated from India in 2004 as in Electronics and Communication Engineering, and then in around 2005 to 8, I was working as a embedded software engineer within in Mahindra Satyam in India. So where I was working for electric park brake systems, where I was developing embedded software for electric park brake systems in automobiles. So in 2008, I came to United States to do my master's in computer science and engineering from California State University, Long Beach. And after my graduation, so I switched my career towards in around 2011 or so. I switched my career towards build and release engineering. So those were the days when it was called as a build and release engineering. So around from 11 to 15, I was working on various tools like Subversion, ClearCase, and build tools like Ant, Maven, and then I worked on .NET technologies like Enant and MS Build, and continuous integration tools like Jenkins and TeamCity. And I was also working on Bash, Python, scripting technologies, and and then around 2015 or so, I moved my careers towards DevOps as an engineer. So I was working from 2000 around 2015 to around 2022. I was working in Apple as a contractor with it for in a DevOps, like as a DevOps engineer. So where I was working as a writing. I'm working on AWS, Docker, Kubernetes, Terraform, again Bash and Python scripting, where I was involved in very key projects of migrating monolithic applications to microservices and writing underlying scripts and technologies for development teams, especially as I already mentioned. At the time, we were handling a lot of developer teams. So that's where I came to know all these, like I worked firsthand with developers to understand their pain points. And so at the time, we tried to automate as much as possible, providing them providing them automation tools so that they can quickly write their microservices and then quickly deploy and test. So after that, I joined. I worked in Flexport. So in Flexport, I joined as a senior infrastructure engineer, where we were actually where I was a part of the platform team, where we were maintaining these backstage internal developer portals. And I was also responsible for maintaining all the part of the team that maintains all the platform, like the pipeline infrastructure, CI/CD, and the again the technology templates that I already mentioned. So yeah, so there we had all this experience of handling development teams. Again, everywhere I go, it's mostly I work very closely with development teams. So and understand their pain points, and from in each org we have a different strategy to eliminate their pains. And so yeah, so and right now I am working again, I'm back to Apple as a contractor, working again on as a site reliability engineer. Here I'll be working on maintaining site reliability, bringing in site reliability tools, and configuring and maintaining site reliability tools and infrastructure for microservices. Yeah, so yeah, it has been a beautiful journey, right from the days of embedded software engineer to being a build and release engineer, handling various tools and technologies, and then transforming into a DevOps engineer, and then handling various projects moving from monolithic to microservices, and also transitioning the whole infrastructure and applications from monolithic microservice, and writing underlying tools and infrastructure. And then and transitioning as a senior infrastructure engineer, where we were maintaining and managing internal developer portals and platform engineering, and then and now the site reliability engineering. So I have my experience in all these platforms. So that's my profile.
Oh, great. Thank you very much. Thank you very much. We, we're going to be having a lot of beginners, probably watching this video later on. Or there are some beginners here. I know somebody's already asking, is there follow-up training or group mentorship? Um, I know we also have a DevOps focus group in the community. I know the person is not aware of that. And, we've done a couple of training on the road to Google Cloud certification on DevOps. But my question now is just for beginners. Probably, let's say, is there an advice for probably a learning path for someone that wants to be going to DevOps that you recommend or suggest, or what,
Yeah.
or resources you want to suggest the person can go through to become a DevOps engineer?
Yeah. So today, definitely, DevOps engineering is it has become a very vast area, and it has become a lot of with horizontal skills. So I suggest for any people who wants to be on the side of DevOps, like learn. I'll give the primary skills, like one cloud tech, like if I ask you, like AWS, Docker, Kubernetes, Terraform, and Python and Bash, for example. Like you can replace AWS with any other one cloud technology, and then one containerization technology. Mostly Docker is very mostly Docker is what is the latest know-how. And Kubernetes is a very important nowadays. All the organizations are using Kubernetes in some or the other way. And then maybe one infrastructure as a code, like the famous is Terraform. So like and then most of the companies are going towards microservices. So all these technologies, tools and technologies are connected to wherever you go. So uh, you are tested on these skills. Uh, and then uh, and then systems design, so very important. Like when you say primary is DevOps skills, is AWS, Docker, Kubernetes, Terraform, Bash, and one scripting language, let it be Bash, Python, or you want to learn Go. You have to be very, very efficient in one of the scripting languages. So, and then and then along with it, you also need to have good knowledge in systems design. Definitely a very important aspect, like because you also need to know the systems, like how systems work. And then you are tested on systems design skills when you go to the interviews. And you also, and then and also data structures and algorithms is not a DevOps field, but still, depending on the company, some companies test you on on the coding part, like uh, some of them are more into data structures, algorithms, or like some of them want to test your coding ability. So you can choose the language of your choice, and they will test you on, hey, write a script to do things, or they will give you a problem and ask you to implement. Because DevOps engineer also need to work closely with development teams. So it's very important that you learn the primary DevOps skills, and also learn the systems design and some of the coding aspects. All these as a combination uh, will help you to get into the field of DevOps.
All right. Very good, very good, very good one, good one, good one. Um, oh, great, great, great. Please, does anyone have anything else to say? Um, that's a good one. That's a good one. Told us about learning, talking of containerization, a cloud tool, could be AWS, could be GCP, could be Azure, containerization, Kubernetes, and what am I missing?
So as I told, like one cloud technology, one containerization technology, and then one infrastructure as a code. I mean, let it be anything, but infrastructure as a code, and some coding, scripting like Python or Bash, and then and systems design, and data structures and algorithms, as like, all this as a combination will help to at least like start a career in
I mean,
DevOps. Yeah, for sure.
there should be at least one programming language still.
One programming language. Yeah, you have to, we have to, yeah, because nowadays it's not only just about like managing tools and infrastructure, and there are organizations expect you to actually write some tools, or they expect you to develop some automation tools, for which you need to have some coding experience or scripting experience, and you need to be able to design systems or think innovatively. So yeah, they definitely expect a DevOps engineer to also have this knowledge. Yeah.
Oh, awesome. What's the time zone where you are right now?
I'm in the Pacific time zone in United States. Yeah, I'm in California, Pacific time
Oh,
zone.
great. Um, it's nice having you, and would love to have you again. If we call on you, or might be calling you on anything DevOps, anything automation, CI/CD. Because we are actually a cloud focused community, so GDG Cloud Port Harcourt, and so anything cloud automation we are in. That's why we found your session very interesting, and I know there's a whole lot. There's every day we still have beginners, we still have people that want to go into tech, people that are hungry for tech, they want to learn new skills, and
Yeah,
so I know we might call you at any point in time, probably.
sure.
Um, that's good, and yeah, you're already giving us your best, and yeah, we're very happy for that.
For
Thank you
sure.
once again for honoring our invitation.
Perfect.
I've not seen any other question again. I think that should be all for now. Uh,
Yeah.
I don't know. Does anyone want to say something? Whether any of the hosts, staff, Dov, are you there? Hmm. All right. So I think that will be all for today. Once again, thank you very much. Thank you for having us. Thank you.
Yeah.
All right.
Thanks. Thank
Okay.
you. And yeah, please, I'm very much happy to share my knowledge, as and when, I'm very happy to be part of the community here and keep sharing my knowledge and also learn from others. Yeah, definitely a very exciting journey that I'm starting, for sure. Yeah, please, yeah, I'm always happy to be part of the community and contribute in whatever way I can. Yeah.
All right. Great.
Thank you. Thank you.
Okay. So bye.
Bye.